Okay, friends, so today what we're going to do is talk about equations again, but through the lens of modeling them. So last week we talked about one-step equations and how to solve those by doing the inverse operations, and we started with coins and pouches. We're going to start there again today. And I'm going to show you three different models for solving an equation that has two different steps actually. So here we have a set of pouches and two extra coins, and then we have some more coins that is the total. And remember, the total coins is however much is over here. So all these pouches, whatever number of coins are in each one, plus these, give me the total. So we're going to write an equation for that. So how many pouches do I have? I have 4 pouches. Now I have 2 extra coins, and the number of coins doesn't change here, so that's a constant, 2. And then the total for these coins is 18. So there's 18 total coins, 4 pouches plus 2 extra coins. So let's think through what we did last week to figure out the number of pouches. When we just had pouches on one side, we were able to equally divide our coins. But now we have these 2 extra coins. Let me ask you a question. Does this total include these 2 extra coins? It does. So we want to get rid of these. So I want to take away these 2 extra coins so that I can figure out just my pouches. And remember, we have to keep our equations balanced, meaning if we do one thing on one side, we have to do the same thing on the other side. So I'm going to take away 2 coins here. Now I have a total of 16 coins. So I took away 2 coins on one side, I took away 2 coins on the other side. And I'm just going to make this visual for us in both ways. So if I take 2 away here, I'm left with 4 pouches and 16 coins. Now I have just 4 pouches, 16 coins. I can split those 16 into 4 equal groups. Well, if I divide by 4, that gives me 4 coins in each pouch. Let's see if that works. I've got 4 here, 4 here, 4 here, and 4 here. Okay, perfect. So there's 4 coins in each pouch. And remember, when we were solving those equations, our goal was to get that variable, the letter that represents a number, by itself. So let's put this into a tape diagram. Remember a tape diagram, we always want to include our total underneath. And then we're going to represent these 4 pouches and 2 extra coins. So I'm going to put my 2 coins here, and I'm going to split this into 4 sections. 4 pouches, 2 extra coins equals 18. Let's do one more of these and then we'll move on. So the next one, number 5. What do we see here? We see 1, 2, 3 pouches and 3 more coins, and that equals 21. So I've got 3 pouches plus 3 coins, gives me 21 total coins. And remember, I want to know what 1 pouch equals. I don't care about these extra coins, so I need to get rid of them. All right, I'm going to take away 3 here, and I'm going to take away 3 off of this end. So I took away 3. 3 minus 3 was 0. I'm left with 3 pouches, and now 18 coins. Now I can evenly divide my coins by the 3 pouches. So if I divide by 3, I get 6. And that should work. 6, 6, and 6. So this is our coins and pouches. Let's do the tape diagram model. Remember, put your total on the bottom, 21 coins. I've got 3 pouches plus 3 more coins. So 3 and our pouches. And if we were to put that 6 in place of those P's, it would all add up to 21. Okay, so that is coins and pouches and a tape diagram model. Now we're going to go to something we call a hanger. So you may have seen these before, you may not, but think about a hanger in your closet. If I put just one side of my shirt on the hanger, it's not going to be balanced and it's going to fall. But if I put equal amounts on both sides, I know that it's balanced. So this hanger here, this right here, is kind of like our equal sign. So what do we see in this first hanger? What do I see on the left? I see 1, 2, 3, 4, 5, 6, 7 ones. What do I see on the right? How many W's are there? There are 3 W's. How many ones? Just one. And in our activity today, we matched up equations and the tape diagrams, but I'm just going to, for sake of time, show you how to solve these hangers. Okay, so just like with coins and pouches, I want to know what one pouch equals or what one unknown value is. I want to know what W equals. So just like with coins and pouches, we need to get rid of the extra stuff to isolate our W. So I've got an extra 1 here. I'm going to get rid of it on this side of my coin or of my hanger. So if I get rid of it on this side to keep it balanced, I also need to take it away here. So just like we did with the coins and pouches, we're going to write our equation. This becomes just 3W, just like here. 7 minus 1, I have 6 ones left. Now I've got 3 W's and 6 ones. I need to split these ones into 3 groups or divide by 3. So I'm going to divide by 3, split them into 3 equal groups, and I get 1 W is equal to 2. Okay? All right, let's look at B. What do you see here? We know that there's an equal sign right here in the middle where our hanger is. I see 2 Z's, 3 ones, and I see 5 ones on the other side. Okay? So, I want to get my Z's by themselves. I need to get rid of this extra ones. I'm going to take away 3 ones. Remember, keep it balanced. Do the same thing on the other side. If we were to write this algebraically, it would look like this. I'm going to take away 3 here. I'm left with my 2 Z's. I'm going to take away 3 here. I'm left with 2 ones. So I'm just showing you how the hanger matches the algebraic way. Okay? So 1Z has to equal what? 1, right? If I divide that into halves or divide by 2, Z equals 1. Pretty simple. So you have 3 models. You have a hanger that you could draw. You have coins and pouches. You also have a tape diagram. And these are all positive numbers. And soon we will get into how to do these with negative numbers. Okay?